So this is how the dependency revision is declared. Down here, under revision, you just put the commit ID. Here is the source YAML file where you define the mapping from artifacts to Git repositories. So this is a pattern that matches group ID, artifact ID, and so on, and this would match anything that comes from group ID JUnit. And what comes from there would be built from here, right? This is, I hope, clear, the mechanism. And here are the steps which would probably answer your question. We are intercepting calls into the local Maven repository with Maven, and if we spot something that has the src infix, we look up in the srcdeps YAML what is the URL for Git. Then we check out the sources locally. Then we change the versions in the POM XML of the source tree in that local repository to whatever revision was requested. We build it and install locally, and the rest of the build pulls the dependency from the local Maven repository. That's it. So now the demo with Maven. We have a very simple project that has just 2 classes. Let's increase the font size. I hope it's readable now, is it? Great. So there's one class saying hello, and the test assuring that the greeting is correct. And this is not flexible at all. We want to assert something better. Assert hello GeeCON, for example. Like this. If I build it now, it would fail because there's no such method in JUnit 4.12. Yes, it fails. And what can we do is to implement this inside JUnit. So we fork JUnit. We find their assert class and create our custom assertion there. It would take just one argument. And would compare it with hello GeeCON, whatever, like this. I need to commit this. I need to check what is the revision number of the commit I have just created. And in the dependent project, I need to initialize the configuration first. We have a nice plugin that can do that. I hope this is the right one. Yes, the module is called init. And let's see what it has done. It has created a mvn/extensions XML file that declares the Maven core extensions. For this demo, only this first one is important. That one replaces the default Maven local repository class with our custom one. And in that way, we can intercept the calls into the local Maven repository. Now, the second class, the second file the plugin has created is the srcdeps YAML file. It has analyzed the POM of JUnit that is available on Maven Central, and it has taken this URL from the POM. But at the moment, we don't want to go to JUnit and send a pull request. We just want to work locally, and that's why I will take this local Maven repository to serve the dependency like this. Okay, is there anything missing? Yes. In the POM file of the dependent project, which is this one, we need to declare the source dependency. And now we will use the commit ID in the JUnit repo that we have just created. What will happen now? It failed, which is a bit expected, but let's have a look what happened. If the failure is what it was supposed to be. The JUnit, the file is not there. There's a syntax problem, sorry. Again. So now we see it's doing something. The srcdeps has detected a source version. It's checking out from our local Maven, from local Git repository to some local directory. It's using Maven versions plugin to set this version, which we have requested in the dependent project, and then it just issues the usual clean install that will install the dependency to the local Maven repo. Further, we will see that the build failed because compilation succeeded, but the test failed because our class is still emitting hello world, not hello GeeCON. So once I change this to hello GeeCON, it should succeed. Yes. Questions about the Maven implementation? No. Let's switch to Gradle. Because we lost quite a lot of time at the beginning, I'll just show you how it looks like, and I will not run it. The srcdeps YAML file is pretty much the same. In build Gradle, there's some code to include the plugin. To include the plugin and to apply it, and here at the bottom we declare the source dependency with some revision ID, and when I run it, it should look pretty much the same. What is important when speaking about about Gradle. It's new and not very well tested, not as good tested as Maven. And my ambition is to support all combinations of dependent and dependency. So either you have Maven or Gradle on dependent and dependency side, and all combinations should work. It's still Maven local repository that is used also for Gradle, which is not that unusual in the Gradle world, and I find it simply quite handy. Okay, that was Maven and Gradle. Now some features that may be interesting for you. As I said, it's possible to declare dependency not only on revision and commit ID. It's also possible to declare a dependency on a branch. The branch is rebuilt every time the tool detects a change in the branch, and it's not rebuilt if the last build was done from the current tip of the remote branch. Okay? This should be tag, not revision. So you can declare a dependency on a tag too. In Maven, source dependencies with this tool work for virtually any kind of dependency, be it usual dependency, test dependency, plugin, Maven parent, and the managed imports, which was quite hard to get. Here's some options in a srcdeps YAML file that you may find interesting, such as verbosity. If something doesn't work in the included build of the dependency, you may increase the verbosity. By default, it's just warn. Then you can put a custom build arguments for your dependency, such as check style skip if you want to build quickly. Skip tests is there by default. There's a build timeout, which is by default very long. I think it's max int. And there's a fail with option, which allows you to declare properties, profiles with which srcdeps shouldn't work. And this is good to avoid srcdeps in releases. The whole reference is available online if you are interested. Now, limitations. I want to give you some context. Where are the borders of this tool? So, can you think of any limitations this has? Sorry? Well, the question was if the usual dependency string already has src in them, right? Yes, then it would fool the tool. But the tool is the first one to see it, so it would take the precedence. Yes? Very good, yes. The tools which have no idea about the tool would see the dependencies as not existent, yes. Yes, you are supposed to know what you are building. Yes, right. it's maybe not finished, yes, and it's maybe very bad quality, and sometimes you exactly want to figure out this. There's a problem, and you want to know that there's a problem. Right. So we support only Git at the moment. Gradle support may be buggy. However, immutable the Git commits are, they can still disappear from remote repositories, and you are better off if you use your own forks that you control on your own. And there's something called build reproducibility. The jars or vars that are built on 2 occasions, even on the same machine and the same environment, may not be binarily the same. And this is not a srcdeps specific problem. That's general problem of Maven and Gradle. It's caused either by environment dependent inputs, such as the user that is building or build time that come into a manifest file. And the second main problem is that the zip specification requires the entries to be timestamped. And as far as I know, Maven team is looking at this to provide some kind of workaround. Then there's one more issue, because srcdeps is building locally, they may, and because the dependent project may define the build arguments for the dependency build. If you have 2 projects on one machine that define the build differently, such as with different profiles or different properties, they may clash, and if you build for a revision, only the first one will be built. And it will be cached in the local Maven repository, and the second one will never be executed, right? So there's a question if you should release your own project if it has source dependencies. The answer is no, definitely no, because the source dependencies with this tool are transparent only to the immediate descendants. And if you would release this to a public Maven repo, you would break your consumers' builds. A similar question, if you should go to production with srcdeps, the answer is why not? As long as your deliverable contains all your binaries. If you produce zip, RPM, or Docker image, and it contains all you depend on and all you are supposed to produce, yes, why not? So, and now, how is this different from Maven's questions? First of all, there are local snapshots and remote snapshot, which behave a bit differently. With local snapshot, what you build is what you get, and you are supposed to build them yourselves into your Maven local repository. It's very handy in day-to-day development on a developer machine, but they are hard to share with your colleagues and on CI, for example. Hard to share, I mean to reach some sort of reproducibility. Because to build the same snapshot on CI and so on is very, very questionable. So now remote snapshots, I personally think they are evil and they should never be used. Because you never know what you get. You never know if you are using the remote one or the one you built locally 5 seconds ago. Maybe in the meantime, the remote one is newer and your build is using their one, and you have no idea why your build is failing. Then they are non-reproducible over time, and you have no control over what the snapshot actually means. The typical strategy to revert to some older revision can't work with snapshots, because snapshots today is the latest one, and next year it will always be also be the latest one. So there are people who don't like changing the versions in POM XMLs. For example, they are well used to building local snapshots for themselves, and for people like this, I added an option to srcdeps that allows to use source dependencies without changing POMs. There are two options that serve the purpose. One is the pattern. So I may say that I either want to build any version or just snapshots, and once this pattern for the given group ID, artifact ID is matched, then this Git reference is used to build the dependency. The caveat here is that it's built every time, and the results may not be cached forever in the local Maven repository, because the tool may not be sure if any other tool has overwritten the result. But this may still be very handy on CI, for example. Right? Now, comparison with other tools that do similar things. Who of you has heard of Jetpack.io? One. Okay. Two. So, Jetpack.io is a remote Maven repository that builds from sources on demand. If you add something like this to your Maven repository, you can declare your dependencies in terms of GitHub user and repository name, and as a version you can use git commit ID. This is quite limited, you may think, as I think, and if you don't want, or if your dependency is not sticking with their convention of group ID, then the dependency must declare a DNS entry on their DNS server, and both of them is controlled by the owner of dependency. So the dependency owner needs to do it for you. With srcdeps, you are fully independent. You can do whatever you want, and you can decide from which commit, how you build, and so on. So, and the same kind of, or similar kind of limitation is that you have no choice over the forks or fork you want to build from. Jetpack knows only one Git repository, and you may not switch even if you want. They don't have the problem of binary reproducibility, because they say they cache, and they build only on the first hit, and it means the subsequent downloads of the artifacts are faster, and the artifact is always the same. Okay, now Gradle composite builds. Who knows them? One? Okay. Composite builds are a solution for local command line, where you can combine several independent trees, or trees that depend on each other somehow, but come from distinct Git repositories into one build. And the big plus, the motivation for Gradle to implement this was primarily to speed up the build process. They can very effectively check what is new, which classes, and so on, and they rebuild just the parts that are new, even if those are span over two independent source trees. Compared to srcdeps, the tool doesn't help at all when it comes to sharing the setup with CI or teammates. If you want your teammate to do the same thing as you do, you would have to write an email and point him to the right Git repositories, to the right revisions in all composed projects, and so on, and the tool doesn't encode this information in any way. And it's Gradle only. As I said, our ambition is to support any build tool. That's basically it. There are just a few things I want you to remember from this presentation. srcdeps is a tool for Maven and Gradle that allows you to declare dependencies in terms of source commits instead of released versions. And the main idea of the tool is to give power to you, the maintainer of the dependent project. You can decide how to build, when to build, what will be the state of the repository you built from, and so on. Here are some coordinates of the projects if you want to look for documentation, bugs, and so on. That's it. We are a bit over time, but I think it's still okay. If you have questions, either ask now or come to me. Thank you very much.